In this video, we will talk about solving differential equations. What is differential equation? The equation that we already took a derivative of. Given below a differential equation with given initial condition. Initial condition is an order pair, like a function, original function, order pair x and y. Find the particular solution. What is particular solution? The answer of the particular solution always is going to be a function y equal f of x for each differential equation that satisfies the given initial condition. Okay, this is dy dx is equal 6x squared plus 6x plus 2 and f negative 1 is equal to. So this is my initial condition, but this is my differential equation because this is 6x squared plus 6x plus 2 is we already took a derivative of. So this is a derivative actually. If it says d over dx, then it means they want me to take a derivative like this 6x squared plus 6x plus 2. Now I have steps right here, 3 steps. I wrote it down. Um, um, we're gonna have like 1 or 2 more steps, but right now it's just 3 for these questions. So cross multiply first, then separate the variables like dy, y's on one side and dx and x's on the other side. So this is the first step we're gonna do here. So since I'm cross multiplying, dy dx means derivative. So I'm cross multiplying. I just put 1 here so I can cross multiply nicely. dy multiply with 1, so it's going to go 1 dy equal, and all the 6x squared plus 6x plus 2 multiply with dx. So I did the cross multiplication first, then separate the variables, which means dx and dy is on dx and x is on one side, and you can see dx and x is on one side. dy doesn't have any y's, but it's on the other side. So we are good to go that step. Second, integrate both sides of the equation. So I'm going to integrate both sides. If I integrate dy, it's going to give me original y. Derivative dy means derivative of y, so it's going to give me original y. Integrate 6x squared, it's going to be 6. 2 plus 1 is 3, and the new exponent goes in the bottom. Again, 6 stays, x has invisible 1, 1 plus 1 is 2, and 2 goes in the bottom. If it's a constant, we're going to make it x, and since we don't have limits, it's going to go plus c. The reason of initial condition is also to get the c, like you get the value for the c, so you can have a really good, nice function as an answer. So I will simplify this. It's going to go 2. This is going to go 3. So I'm going to write this one more time. 2x cubed plus 2x squared plus 2x and plus c equal y. Plug in initial condition. I integrated both sides, plug in initial condition and get c. So I'm going to plug in initial condition. Y is 2 and my x is actually negative 1. I'm plugging in wherever I see x, negative 1. When I solve this, it's going to give me negative 1 plus c. That's a 2. Add 1 both sides. And it's going to give me c equal 3. So this is going to get you 1 point right there. I'm gonna show you how they distribute the points on this and why you are getting so many points on this one question. So I got c equal 3. Now they said get c, which we did, then this will be your particular solution, a function. So it means I have a f of x function, and you know this is my f of x function. So I have 2x cubed plus 2x squared plus 2x. For the c, I plug in 3. This is the answer for a particular solution. Okay, let's try question number 2. Question number 2 is kind of complicated, so we're going to strictly follow our steps. So we're going to cross multiply this first. So let's cross multiply this. So I'm going to go dy 2x and half equal. Then I do dx plus 12x 3 over 2 and dx. Now, this one is good. This one looks good because 1 plus 12 and this 12x to the power 3 over 2, this is one whole function. So the whole thing goes with the dx, which is perfectly fine. This is x variable. But this one is a kind of different thing because x is with a dy. That's not okay. So we have to divide 2x and a half both sides. They cancel out. Then I divide 2x and a half here. I'm going to divide 2x half here. So whatever I left is 1 over 2x half plus, I can simplify this, make it 6. And 3, x and x are exactly the same basis and they are dividing, so I can subtract the exponent. If you subtract 3 half, subtract half, it's going to give me 2 over 2, which is 1. So it's going to go just 6x, and I still have the dx. It looks pretty good, and we are okay, except this portion if I'm integrating the next step, because this is like a quotient rule, so I can separate this and make it x negative half. Instead of this, I can make it x negative half, like this. Then we are okay. Now integrate. Once we integrate both sides of the equation, you integrate dy, it's going to give me y. Half is going to stay as a half. Coefficient always stays and it doesn't go for integration. Negative half plus 1 is going to give me plus half. And exactly the same half goes in the bottom. Plus 6x squared, and the 2 goes in the bottom. Plus c. Now I have to fix this. Half, when we do the reciprocal, it's going to go 2 over 1. Right? And they cancel out each other. They cancel out right there. So I'm left with x half. This one we can simplify as a 3. So I got y equal x half plus 3x squared plus c. Now I can plug in my initial condition, and that's my third step. So my y value is 2 and everything else is 0. So this is 0 half. And this is 3 squared plus c, which means this whole thing is 0. So c is equal 2. Okay, now I have to make sure that I have my function ready for the answer. It's going to go f of x, and you know that's my function f of x. So I have f of x equal x square root plus 3x squared plus 2, and that's my answer for this question. Okay, question number 3. dy dx x squared plus 2x over 2y, and this is my initial condition. So I have to cross multiply first. Make sure we cross multiply first. So I got dy and 2y equal x squared plus 2x and dx. This cross multiplication, when you fix the y's and the dy's and x and the dx's on either side, then it will give you 1 point. And in this one, they are already on the same side, so I'm okay. All I have to do is integrate and integrate. When I integrate 2y dy, like for example, if I have a dx here, then for example, I have a 2y, then I have a dy. In the upper portion, I integrated dy as a y because there was 1 there. If you guys pay attention, this was 1 over here. So 1 is a constant. 1 integration is going to be y. For the dy, it just disappears with the integral sign. So I have to integrate 2y. It's going to give me 2y square over 2. The dy and the squiggly line integration sign disappeared. So this is what it is, okay? There was 1 there. I should have explained it. There was 1 there. So when I integrate 1, it's going to give me y. Like every constant is going to have a 2, 1y, or if I had a 2, then 2y and 2x or something like that. X cubed over 3, 2x squared over 2 plus c. Now I have y squared. I'm just going to y squared, and this is 1/3 x cubed. 2 cancel out. I got x squared and I got a plus c. Now I'm done here. Now I have to get the initial condition, which is 0 and 2. So this is actually 2 is my initial condition for y, so it's going to turn 4. Everything else is 0, so I got c. I don't have to put it in here. So this is what it is. And let's do the particular condition for it, particular solution. This is my c is equal 4, but this is not y by itself. We have to get the y by itself, so it has to be square root. So if I do this, it's going to give me y equal 1/3 x cubed plus x squared plus c, and this whole thing is in the square root. And c is 4 actually, so I can plug in that 4 there. And I have to get the y by itself. So plug in initial condition. Okay, then now this is good. Get the y by itself. Okay, so this is what happened, and we get the y by itself. We got plus c and all that stuff. Now, when we square root something, we know we get two answers, positive and negative. How do we decide our answer is positive or negative, or which one it works for us? Because it has to be one answer. So you look at the condition, your condition f of 0 equal to. So if I plug in 0 here, like for example, I plug in 2 here, and then I'm going to plug in 0, so it's going to be 4 square root, right? When I 0, 0, that turns 0, 4 is a square root, so which means 2 is equal to. And positive 2 is equal positive 2. So the positive one is working. But if I plug in negative, like for example, I plug in 2 equal, and this is negative square root, that was positive actually, and this is negative, so it's 4, it's going to give me 2 equal negative 2. So this is not okay. So negative is not working, but positive does. So this is not working for us. So my answer is positive 1/3 x cubed plus x squared plus 4. I'm going to write my answer in blue up here somewhere. I got y equal positive 1/3 x cubed plus x squared plus 4, and everything within the square root. There, that's my answer. Question number 4. Let's do question number 4. Cross multiply again. We're going to cross multiply. I got dyy. I got x plus 2 and dx. And if you guys look at it, they are all good and perfect. X plus 2 is one whole function right there. So it goes together with dx, like 2 and x goes together. They are dx, they are dy, fine. I'm going to integrate both sides. Once I integrate, y is going to give me y squared and half, like divided by 2. This is going to give me x squared and again half, plus that's a constant, it's a 2x, and I have a plus c. Plug in the initial condition now. So y is negative 3, so I got half negative 3 squared equal half, and 1 is my x squared, 2 squared plus c. 3 times 3 is 9, 9 over 2. That's half plus 2 is going to give me 5 over 2. You guys can do the fractions plus c. Subtract 5 over 2 both sides. Subtract 5 over 2 both sides. They cancel. I'm getting c equal 9 over 2 subtract 5. So 9 subtract 5, since the least common, the denominators are the same, so I'm just subtracting straightforward. 9 subtract 5 is going to give me 5, 6, 7, 8, 9, 4 over 2, which can be simplified to 2. So my c is actually 2. That's my c. Now plug in, get the original, get the y by itself first. Now my function, the one I have here is that one. So I'm gonna go and get the y by itself. So I'm just writing it here. Half y squared, half x squared plus 2x plus c. Get the y by itself. We means I have to multiply by reciprocal, like 2 over 1. Multiply everything by reciprocal 2 over 1, or just a 2. They cancel out. I'm left with y squared. When we multiply, they cancel out. So I got x squared, 2 and 2 is 4x plus 4x. And c, we already know c is 2, right? I should have plugged in c2. 2 times 2 is 4 again. There you go. And now I have to do the square root. They cancel out, and I'm left with y equal positive negative x squared plus 4x plus 4 square root. Now, is it positive work or negative work? I don't know. I have to plug in my initial condition here right now in the answer and see if I'm going both sides the same. So this is negative 3 when I plug in. And if I plug in positive 1, for example, positive 1, and it's going to go 1 squared plus 4 times 1 plus 4. 4 plus 4 is 8. 8 plus 1 is 9. 9 square root is 3. It's positive 3. So that's not working. It means negative is going to work because my y value is negative. So I'm supposed to have a negative answer here. So it's negative 3. So negative is the one is my answer. So I'm going to erase all of this and erase positive. And my answer is y equal negative square root x squared plus 4x plus 4. Done. Okay, let's do question number 5. Cross multiply again. Cross multiply again. Since this one doesn't look like a fraction, then I'm going to make a fraction, like I'm going to put 1 there. dy times 1 is dy. 1 dy. This is going to go x squared, x to the power 4. Sorry, not squared. X to the power 4. And I got y minus 2 times dx. Like I cross multiply this too. Now I know x4 is okay with dx, but y minus 2 is not okay. So I'm going to divide this y minus 2 to move it back to where the dy is. Cancel. And I'm left with, what am I left with? 1 over y minus 2. So I'm left with the 1 over y minus 2 in dy equal x4 dx. Next step, integrate. Integrate. Now, I said that before, when you in integration, you get 1 over some variable with the exponent 1, then that means that's exactly, I have my ln absolute. Whether it's an expression like this one, y minus 2, or it's just a single variable like 1 over y, 1 over x. These are all my ln's if I integrate 1 over a, 1 over b, 1 over z, anything. But it has to be exponent 1. I can do that's ln, and also I can do these expressions as an ln as long as the variable is just has exponent 1. That's what it is. So I'm going to go and integrate. So it's going to give me ln absolute y minus 2. I got that. Equal dy disappear, integral sign disappear. X4 means 1/5 x to the power 5. I'm doing 1/5 already because it makes it easier instead of doing x to the power 5 divided by 5. And I have a plus c. Now I got all of that. Plug in my initial condition. So my initial condition is 0, like y and x both 0. So ln 0 minus 2 equal 0 to the power 5 over 5 plus c. So technically this one I got ln 2, it's negative 2, so when I take it out from the absolute, it's going to turn positive 2, and I got c. So my c is ln 2, and I'm good to go. Now I have to go back and plug this in my function, the one I got, which is this one in this case. So I'm getting ln absolute y minus 2 equal 1/5, right? 1/5 x to the power 5 plus ln 2, which was my c. Done. Now, how do I get the y by itself? Because y is with y minus 2 absolute, and it also has a ln. So, about one thing at a time.
How do I get rid of ln? Ln you can only get rid of if you make base e. So I'm going to make base e there. I'm going to make base e there for this whole function, like 1/5 x5 plus ln 2. I'm going to make a base e's. They cancel out. Ln and e cancel out. I'm left with y minus 2 absolute equal. And then I have this. Now this is e to the power 1/5 x5 plus ln 2. This whole thing is an exponent of e. So how do I make them separate? Like, what I mean by this. If I have x times x and this is 1 and 2, same basis, multiplying, we add exponents, 1 plus 2, right? If I have something like this, I can go back and change it to this, right? Like this. So I'm going to say e 1/5 x to the power 5 times e ln 2. See, I separated them. Like I separated these two exponents. These two are my exponents, guys. I separated them, and I mean, it's the same thing. I just rewrote them backward. If I do this, they cancel out. So I'm left with actually y minus 2 in the absolute. I got e 1/5 x to the power 5 again, and times 2. They cancel out already. Now, how do I make everything else change? How do I get this out um, from the absolute? So if I take this out from the absolute, like y minus 2, make sure that you have a negative here. Negative 2 e 1/5 x to the power 5. And I'm going to have another one. Absolute give you two things, like positive and negatives. Another one, or we can say y minus 2 equal positive 2e 1/5 x to the power 5. Now, I don't know which one works in this case, in this situation, which one is going to work, but I have to change both of them to get the y by itself first. So I'm going to go and change this one to y by itself. It's going to go y equal negative 2e 1/5 x to the power 5 plus 2. Okay, and I'm gonna go and get this one y by itself, which is gonna give me y equal to e 1/5 x to the power 5 plus 2 again. So this is what I'm getting in both conditions. Now, which one is true, which one is not true? Absolute give you, when you take it out from the absolute, some expression, make sure that you have two answers for it, positive and negative, like a square root. Now, I'm gonna plug in my conditions, and my condition is what is condition? 0, 0, both. So if I'm going to give me 0, 2, e 0 plus 2. So this is term 2 plus 2, which means 4. So 0 is equal 4, which is not true. So this one is not working for us. Like that one is not the answer. If I go there, 0, I can try it. E 0 plus 2. So negative 2 and positive 2 is going to give me 0 equals 0. So that one works. So my answer is this. Like that. Sorry. Okay. So now I have a question number 6. Multiply first. So I got dy x squared equal y minus 1. That's together dx. And that's very wrong. Like this one is y and it's a dx side. This is x and that's a y side. So I'm going to move them both around. This is going to go, for example, y minus 1, I'm going to divide y minus 1 both sides. So I got dy 1 over y minus 1. In this one, I'm going to go 1 over x squared and dx. So integrate both sides. When I integrate this is ln. We already know because I have 1 over y. This one is going to go x negative 2. So negative 2 plus 1 is going to give, so it's negative 1. And this is also negative because negative 1 in the bottom. So this is what I got so far. Now let's fix it around. I got ln y minus 1. This is going to give me negative 1 over x plus c. plug in initial condition, which is 0 for the y. So ln 0 minus 1 is going to give me positive 1 when I take it out. That one is going to negative 1 over 2 plus c. So ln 1 is always 0. We already know that. And this is negative half plus c. So my c is equal actually positive half. Done. Now replace that c so I can get my particular solution. And this is the one I'm going to use, the function f of x. So I'm going to say ln y minus 1 absolute negative 1 over x plus half. I have to get the y by itself, and we know we're going to have a e base because I cannot get rid of ln. So this is e, that's e. This whole thing is an exponent. This whole thing is an exponent. They cancel out. I'm left with y minus 1 absolute, and I'm going to separate them like I did before. So it's going to give me e negative 1 over x times e half. So I separated them. Now let's try to separate and take it out from the absolute. When I take this out from the absolute, I'm getting, what am I getting? Negative e, negative 1 over x, and I have times e half. Then you can add plus 1 both sides, right? So this is one, this is one. Another one I'm getting, y minus 1 equal positive e negative x times e half, and I can do add 1 both sides and cancel. So which one is going to work? I don't know. We have to plug in the conditions. So the conditions are 0 and 2. So my y value is 0. I have negative e, I have a 2. Never mind. So this one is going to give me, when I multiply same bases, I actually adding exponents. So if I add exponents, it's going to give me 0. So I got negative e to the power 0 plus 1 equals 0. Then it's negative 1 plus 1 equals 0, which is 0 equals 0, which means this equation works. That one is good because I'm getting the same both sides of equal. But this one shouldn't be working. Let's see, half times e half plus 1. Then this is going to give me E0 plus 1, which is 1 plus 1, and it's 2. 1 plus 1 is 2. So not okay. This is not possible. So the answer is that. You can simplify the answer like really nicely and neatly to write it down. So your answer is y equal that one I'm talking about. Y equal negative e negative 1 over x plus half. I'm just putting them together again, plus 1. Like make it simpler. So that's my answer for that one. Okay, we have 2000 AP Calculus AB free response question number 6. They said consider the differential equation right there. Find a solution y equal fx to the differential equation satisfying f of 0. So that's my initial condition actually. That's my initial condition, x and y. They said y equal f of x will mean they are asking for a particular solution because particular solution answer is supposed to be as a function. So part A, I'm going to write my question first, dy dx equal 3x squared over e square, and e square, this is actually wrong. This is not e square. This is ey. So this is ey. Okay. Now I'm going to cross multiply first. That's our first step. So I'm going to have dy ey equal 3x squared, and I have a dx. Integrate, they are already fixed. Y's and y's on one side, x and x is on another side. So they are good. Take the integral of ey. Ey integration is ey. We know that. Take the integration of this. It's going to be cubed divided by 3 plus c. They cancel out. Plug in the condition, which is 0 and half. The condition is 0 and half. So half is my y value, e half, and that's 0 plus c. So my c is equal e half. That's my c. Plug the c back in the function so we can get it. So I'm gonna have, this is my function actually, but I have to get the y by itself before I do that. But ey equal x cube plus e half. So I have to get this e by itself, y by itself. So if I'm getting y by itself, getting rid of e, then I have to do the ln both sides. And ln is not a base, it's going to multiply like this. So they cancel out. I'm left with y ln x cube plus e half in the parentheses. So this is, I got the y by itself, and this is what my answer is. We can do anything else with it. You can make e as a square root. That's another thing. Okay, let's see. What part, other part? Part B said, part B, find the domain and range of the function found in part A. So this is my y equal ln x cube plus e half. For the domain, always, we pick the inside, like the argument or under the square root functions, expressions, and then make them greater than 0. So I'm going to get x cube plus e half greater than 0. Then it's going to give me, actually, it's a domain that they're asking, so I need to get the x by itself. So I'm going to go x cube greater than negative e half. To do the cubic root, then I always do times 1/3 times 1/3 both sides. They cancel out. I'm left with x greater than negative e. They are multiplying, so it's going to give me 1/6 e 1/6. So this is my domain. And done. That was kind of easy. Then you have a day 63 homework. If you guys have any question on this, please let me know and I'll make a video on this one. Thank you.